Hello ladies and gentlemen. This video is geared towards anyone entering an introductory calculus course, and that can be either AP Calculus AB or an introductory calculus course at the college level. The reason why I'm making this video is because 125,000 people took the AP Calculus BC exam when I took the exam, and I want people to be prepared for when they enter the classroom because I had no idea what I was getting myself into. So throughout this video, I'm going to cover what you should prepare for in the classroom, what mathematical foundation you should have. I'm going to cover what the definition of a derivative is, the power rule with differentiation, and some other derivative rules. And I will have annotations listed here because I believe this video will go very long, but everything in here will be useful, and I hope you guys hold on to every word that I say. So let's jump into it. When you are preparing for the classroom, I highly recommend getting a Ti-nspire CX-CAS. And the CAS stands for Computer Algebra System. And the Computer Algebra System helps you out with so many different things. It's very useful. I'm not trying to advertise the calculator, but I highly recommend getting it. It helps you with systems of equations. It helps you with graphing. It helps you with so many things. And it's completely fine with being used on the AP exam, and it's only $130. And for some people that might be a pretty steep price, but you can pick up on eBay for less than $80. And while that might seem like a lot for a calculator, it is very solidly built. You can drop it so many times and it'll be worth it because it will survive everything you throw at it, and it's so useful for everything you're going to be doing in the class. Next, I believe you should pick up a full 200-page spiral notebook. And this is for taking notes, doing problems, and anything else you may need that involves calculus, because if you take the class in high school, you spend 180 days in the classroom. And that is if you take A, B, and BC. Spending 180 days in the classroom doesn't mean you'll take a page of notes every day. You may spend half a page of notes every day. You'll also probably be doing lots of homework problems, depending on your teacher, depending on your professor. But I recommend getting that full 200 pages because it's in a really nice sweet spot for how long you'll be in the class, for how much work you'll be doing. Next, I definitely recommend picking up the textbook before you take the class, and this is really useful for college students, whether you download the textbook or you purchase it or whatever your method of obtaining it is. Get it before you take the class, because when you read ahead, you're really putting yourself at a huge advantage. And this works for high school students as well. When you read ahead, you'll be ready for whatever the teacher's going to throw at you in the beginning of the course and the end of the course. When I took Calculus 3 and differential equations, I would read the textbook for an hour before every class, and I wouldn't even read it really for an hour. I'd read it, off and on for a different amount of time depending on the chapter. I would read before the chapter would start, or before the class would start, my apologies. And when I entered the class, I knew everything that the lecture was going to be on, and my teacher let me walk out early on about 7 different occasions. So I highly recommend picking up the textbook as soon as you can and reading it before you're ready for it. I know high school students, this is where you're at a disadvantage. You can't just get up and leave because that is illegal. But when you read ahead, you're setting yourself up maybe for boredom, but mostly for success. Because if you know everything that you're going to be getting yourself into, you're going to get that A, you're going to get that GPA boost, whatever that may be, whether it's a 4 or 5. Either way, get the A by reading ahead, because reading ahead, it helps you in more ways than one. Like, when it comes to math, all you need to do is be able to speak the language your textbook's printed in, because everything has proofs. Everything in the Calculus 10th edition textbook that I have listed here, everything in there has a proof. And so everything that you need to know is in that book. You don't even need to take the class. If you study that book intensely, you do all the practice problems, you can get a 5 on the calculus exam. And my final notes for classroom preparation is be ready for busy work. Depending on whatever previous math teachers or professors you've had, you may have done a relatively light amount of busy work, or you may have just been slammed by busy work. But be ready, because when it comes to calculus, in the early stages, they throw a lot at you and they make you do a lot of problems. And being ready for that is something that you want to be mentally prepared for, because anyone can be physically prepared for writing. I mean, if you take a U.S. history course, if you take an English course, you probably write a lot pencil paper. But being mentally prepared for the sheer amount of problems you're going to be taking is something I highly recommend doing. Next, let's get on to your math foundation. You got to understand how a function works and why a function's a function. So you have basic input-output, that's a function. Not quite. A function is anything that you may have learned that passes the vertical line test. And the vertical line test is if you can draw a vertical line through it and there is only one point that it goes through at all points of the line, or whatever function it may be, it is a function. So as long as you understand that, you'll be ready for the first month of calculus. But let's get a little bit deeper into it. You got to have a strong foundation of algebra. Calculus is all algebra based, and if you don't have a good understanding of algebra, you're probably not going to succeed. I don't really like algebra too much. I'm not good at it, but for some reason I'm good at calculus, and maybe I'm the exception to my own rule. But if you have a strong foundation of algebra, there's no doubt that you'll be able to do fine in calculus. If you got A's in every math class up until this point, you're probably on track for getting an A in calculus. But as long as you have an algebraic foundation at the core of your math knowledge, you'll do fine. The next point I have listed here is you want to be able to swap back and forth between y equals and f of x. And this is really just me because I didn't pay attention in all my math classes. I only used y equals because I'm so stubborn, and I didn't even consider f of x existing up until taking calculus. So when I saw the notation of f of x, I was just like, I don't understand what this means. What is going on? Why? Just give me y equals. And f of x shows up more times than y equals will in calculus AB, calculus BC, differential equations, multivariable calculus, linear algebra. You're going to see f of x beyond the pre-calculus and trigonometric levels. So that's really one of my notes, only because I was stubborn, didn't care, didn't pay attention. Next, let's move on to limits. A limit is very simple, and I'm going to explain it now in case you don't already know. If you already know it, don't bother listening. But a limit is basically a variable approaches a number, and it's going to be written in the notation lim, standing for limit, as your variable approaches a number. So in this case, in this instance, it is limit as the variable x approaches 0. And now for an example of that, we have the limit as the variable x approaches 3 in the function x plus 6. So x plus 6, we take the limit as x approaches 3. So we replace x with 3. 3 plus 6 is equal to 9. Finally, as long as you know a little bit of trig, whether you took trigonometry and pre-calculus, or if you took trig, or if you took pre-calculus, as long as you have a little bit of an understanding of trig before going into, you'll do fine. When trig comes in probably about 2 months into the course, or if you're at the college level, maybe 5 or 6 lectures in, you'll start talking a little bit more about trig functions. But as long as you understand why a sine wave is a sine wave, why a cosine wave is a cosine wave, you'll do fine. If you don't know this stuff, it's okay. Probably everything you'll need to know will be taught in class at the college level. If you have a good math teacher in high school, everything you'll need to know will be taught in class for the AP exam. Next, let's move on to the definition of a derivative. Now, according to mit.edu, the derivative is the instantaneous rate of change of a function with respect to one of its variables. This is equivalent to finding the slope of the tangent line to a function at that point. So let's take the first part. It is the instantaneous rate of change of a function to one of its variables. Now let's go down to the notation of the definition of a derivative. This is the mathematical definition of a derivative. So it will be in the terms of f prime, that's what the little apostrophe stands for, is f prime of x, or y prime, or d over dx. And we'll get into that in a little bit later with the derivative rules, because that's what it's written for in a lot of the rules. So the definition of a derivative, we have f prime here, and here's where limits come in. The limit as the variable h approaches 0 of f at x plus h, so your function of x plus h, minus f at x all over h. Now getting to the instantaneous part of this first half of the definition, h represents the step variable. So you're taking essentially a non-existent step. So it is basically where will the function go if you didn't take a step, or where, like, what is it projecting into? Projections you get into later, but what does it look like the direction this function is going into? So now let's do a little example here. Y is equal to 2x plus 3. This is very, very simple, but you notice that it's in terms of y equals mx plus b. We know that the slope is 2. But now we're getting into the second half of this definition, the slope of the tangent line. So y is equal to the limit as h approaches 0, going to the definition of 2 times x plus h, because we replace x with x plus h in the first half. So 2 times x plus h plus 3 minus 2x plus 3, all divided by h. Next step, y prime is equal to the limit as h approaches 0. After multiplying it out, we have 2x plus 2h plus 3 minus 2x plus 3, all divided by h. The 2x's and the 3's cancel, and we're left with 2h divided by h. And the h's will cancel, and we get 2. Now the slope of this function is 2. And that is something that you'd know, because slope from algebra is rise over run, so we know that y equals mx plus b, m is the slope of the line. Let's get into a different example. So say we have the function f is equal to x squared plus 2. Following the limit definition of prior, we have f prime at x is equal to the limit as h approaches 0 of the function x plus h squared plus 2 minus x squared plus 2 all over h. When you FOIL out the polynomial, you get the limit as h approaches 0 of x squared plus 2xh plus h squared plus 2 minus x squared plus 2, all of that divided by h. So now let's take a look at the picture. X squared plus 2 looks like this. Now let's continue on. So we have f prime is equal to the limit of h approaching 0 of 2xh plus h squared all over h. And now we've got f prime of x is equal to the limit of h approaching 0 of 2x plus h. Now as h equals 0, we know that that becomes 0, so that means the derivative of the function x squared plus 2 is equal to 2x, and this is what the line would look like. So this means that whatever point on the y side of this line, so whether it's in the negative or positive, x is the independent variable, y is the dependent variable. Whatever the dependent variable occurs, what it turns out to be is what the slope of the line tangent to this. So at point 0, the slope at this point right here at x equals 0, the slope of the line tangent to it would be equal to 0. And this is something that you'll cover in the class in more detail, but really the derivative will give you a function that when you input a point will give you the slope of the line. So if we go back to the previous example, the slope at this line, because it's a line, will be constant throughout every point. So the function of the derivative will give you the slope of the tangent line at a specific point. Well, at all points, the slope of the line tangent to this would be 2 because it's a constant line. In this case, the slope of the line tangent to this function, x squared plus 2, will be equal to 2 times whatever the x variable is. And like I said, you'll go into that in a lot more detail. Now let's go to the power rule. Here's where the notation of a derivative comes back to d over d of x. And then we have a function x to the power of n. The derivative of that function x to the power of n is equal to n times n minus 1. So from our previous example, you can skip all that work from y is equal to x squared plus 2 to just y is equal to 2x, because n is equal to 2, so 2 goes in front as the coefficient and 1 becomes the power. I cannot stress this enough. I didn't understand the definition of a derivative because I just didn't understand algebra because I'm an idiot. I went through the first 2 months of calculus not knowing what the definition of a derivative even meant. I just followed the power rule. If you understand that everything I'm saying is going to go along with what you're going to learn in class, you can skip through the first month and a half, maybe even 2 months of your AP Calculus course, or your introductory calculus course just by understanding the power rule, because the first week or so is probably going to cover functions and how they work. Then it's going to uncover the reason how the definition of a derivative was formed, and that's based on Isaac Newton's work and all that other stuff I don't need to get into. But if anything, understand the power rule before you get into class. Now let's do a different example. This part, x to the n power, the derivative of that is n times x to the n minus 1, that covers for any variable n or any number n in the power. So say we have the function y is equal to 6x cubed plus 4x squared plus 3x plus 6. We get 18x squared plus 8x plus 3. So in this case, the 3 drops down to a 2, and 3 times 6 is 18. In this case, the 2 drops down to a 1, and the 2 times 4 is equal to 8, and the 1 drops down to a 0, and the 1 times 3 is still equal to 1. So the function that would give you the slope of the line tangent to this function right here is 18x squared plus 8x plus 3. Now we're going to get on to derivative rules. I would recommend pausing this screen. I'll get my cursor out of the way so you don't have to see that. I would recommend pausing the screen right here, and you don't need to print this out. I would just make sure that you either write all these out or screen cap this and leave it somewhere, because you're going to need to know all of these. And you'll know all of these by heart by the time you end calculus if you study hard enough and you understand all these rules. So I'll go down the lines. The derivative of a constant c is equal to 0. Notice in the previous example, 6 didn't have a variable attached to it. Therefore, there was no power for it to drop by. Plus, if we go back to the definition of a derivative, we note that constants cancel out. So the derivative of a constant is always equal to 0. And you could visualize that with, say, just a straight horizontal line, like y is equal to 3. That line has a slope of 0. Therefore, there cannot be a slope to the line tangent to that, because you'd basically be dividing by 0. There's no way for you to do that. So the derivative of any constant number, c, and whatever, is equal to 0. Power rule, again, I pulled these pictures off the internet, so you're going to see this again. Constant multiple rule, c times u if you're deriving with respect to x, u being your function, whatever, c constant times function u of du dx, the derivative of function u with respect to the variable x. So this goes back to right here. 6x cubed, that's your constant 6 multiplied by the power 3 becomes 18. Sum and difference rule, the derivative of u with respect to x plus or minus the derivative of v with respect to x. It's going to be the derivatives of the functions, whatever, plus or minus. Product rule, if function u times function v is going to be u times the derivative of v plus v times the derivative of u. All of these are going to be covered. And now this one was my favorite one. Just to talk out, I didn't really actually like doing the problems associated with it. But say you've got a function u divided by the function v, and you got to take the derivative of it. You take the first function times the derivative of the second minus the second function divided by the derivative of the first. I'll take that, divide that by the bottom one. So, or low d high minus high d low, draw a line, square the low. That's a very constant rhyming scheme, or whatever scheme that is. I'm not a word guy, I'm a math guy. Whatever helps you remember that. Low d high minus high d low, draw a line, square the low. That's how you understand the quotient rule. Now let's go into just some trig stuff over here. We've got y is equal to sine x. The derivative of that would be cosine x. The y is equal to cosine x. The derivative of that would be negative sine x. Tangent x becomes secant squared. Cotangent becomes negative cosecant squared. Secant x turns into secant times tangent. Cosecant becomes negative cosecant times cotangent. You'll learn all these rules later, but it's good to know ahead of time, and if you pause this, like I said, you'll be fine. Now you're done. You've sat through this video. What do you want to take away from this? If you want to succeed in the class, read. All you got to do is read. Also, you don't need to buy the Ti-nspire CX CAS. I believe you can get away with just using an 84 anything else like a simple 4-function calculator is also acceptable in the exam, but get comfortable, get familiar with whatever calculator you plan on using. Now, everything that you need to know for the class, say you don't understand something like you'll get into Taylor polynomials and Riemann sums. If you don't understand those, all you need to know is that you can find help online, whether that's Khan Academy, whether that's me if you want me to do anything, with something you don't understand from the class. School starts up in less than a month now, so anything you want to know, I can help you out. Finally, if you're in an AP Calculus course, take the AP exam. It's $93. You can get a fee waiver if you can't afford that, but oh my goodness, it is entirely worth it taking the exam, because the likelihood of you earning credits, depending on whatever school you apply to, whether they take 3s, 4s, or 5s only, doesn't matter. The likelihood of you earning a passing score is so high that if you don't take the exam, you're going to throw your money away in college because you've already learned everything you're going to need to know. When I took it, it cost $93. It may cost $92, it may cost $90. Whatever they're changing the price to, take the exam. Because the price, say you go to a community college, the price for in-county tuition, so if you live in the county of the community college you attend, it's around like $135, $136, maybe more, maybe less, per credit, which means the cost of that 4-credit class, because normally math classes are 4 credits, you're shelling out close to $500. Or you can take the AP Calculus BC exam for $93 and potentially get up to 8 credits. There's no reason not to. Plus, if you don't get the passing grade, you're already familiar with calculus. You're going to pay for the class anyways in college, and you'll succeed later. But save the money. Oh my God, AP is so useful. Unless you're going to a college where AP isn't necessary, don't take it, but take the AP Calculus exam. If you're not in calculus at the AP level at high school, I'm sorry, you're paying for the class anyways. You got to take the exam if you want to pass, because usually exams will determine your final grade, whether it's going to stay at an A, drop down to a B, drop down to a C, bump up to a B, bump up to an A. That's all I have for you guys. I hope you sat through this video because it was a blast to make. I actually want to make more math videos aside from whatever I've been doing. So, thank you for watching.